Tell us what Evolve is.
Well, at a high level, it's basically taking our latest Gemini models, actually two different ones, to generate sort of ideas, hypotheses about programs and other mathematical functions. And then they go into sort of evolutionary programming process to decide which ones of those are most promising. And then that gets sort of ported into the next step.
And tell us a little bit about what evolutionary programming is. It sounds very exciting.
Yeah, so it's basically a way for systems to kind of explore new space, right? So like what things should we, in genetics, like mutate to give you a kind of new organism. So you can think about the same way in programming or in mathematics. You change the program in some way, and then you compare it to some answer you're trying to get, and then the ones that fit best according to a sort of evaluation function, you put back into the next set of generating new ideas. We have our most efficient model, sort of flash model, generating possibilities, and then we have the pro model critiquing that, right, and deciding which one of those is most promising to be selected for the next round of evolution.
So it's sort of like an autonomous AI research organization almost, where you have some AIs coming up with hypotheses, other AIs testing them and supervising them. And the goal, as I understand it, is to have an AI that can kind of improve itself or over time or suggest improvements to existing problems.
Yes. So it's the beginning of, I think that's why people are so excited about it, and we're excited about it. It's the beginning of a kind of automated process. It's still not fully automated, and also it's still relatively narrow. We've applied it to many things like chip design, scheduling, AI tasks on our data centers more efficiently, even improving matrix multiplication, one of the most fundamental units of training algorithms. So it's actually amazingly useful already, but it's still constrained to domains that are kind of provably correct, right? Which obviously maths and coding are. But we need to sort of fully generalize that.
But it's interesting because I think for a lot of people, the knock they have on LLMs in general is, well, all you can really give me is the statistical median of your training data. But what you're saying is we now have a way of going beyond that to potentially generate novel ideas that are actually useful in advancing the state of the art.
That's right. But we already had these. This is another approach, AlphaEvolve, using evolutionary methods. But we already had evidence of that even way back in AlphaGo days. So it's AlphaGo came up with new Go strategies, most famously Move 37 in Game 2 of our big Lee Sedol World Championship match. And okay, it was limited to a game, but it was a genuinely new strategy that had never been seen before, even though we've played Go for hundreds of years. So that's when I kicked off our sort of AlphaFold projects and science projects, because I was waiting to see evidence of that kind of spark of creativity, you could call it, right, or originality, at least within the domain of what we know. But there's still a lot further that has to, so we know that these kinds of models paired with things like Monte Carlo tree search or reinforcement learning planning techniques can get you to new regions of space to explore. And evolutionary methods is another way of going beyond what the current model knows to explore, force it into a new regime where it's not seen it before.